All right. Hello and welcome to the BEST webinar series. I'm Megan O'Neill, your moderator for today's webinar session. Today we'll demonstrate how to streamline manifold assembly with the MDTools 900 series. This webinar will last approximately 45 minutes. You'll be able to submit questions or comments at any time during the webinar by posting in the questions section located within your webinar control panel. Questions may be answered as they are posted, or we'll try to address them in the last 5 minutes of the webinar. Note that today's session is being recorded and that the audio is muted for all attendees. If you are experiencing any technical issues, please use the chat window to alert our support staff. Now it is my pleasure to introduce our speaker for today's webinar session, Carlo Molon. Carlo has worked in the hydraulics industry for many years and currently manages application sales and training at BEST for desktop and cloud products. Carlo?
Hello, Megan, and thank you all attendees for joining today's webinar. So in October last year, we had a webinar regarding manifold assembly rules. It was basically made on Inventor. I promised a webinar on SolidWorks for the same topic. So today we will be using SolidWorks, and I'll show some techniques how to create bolt kits using configuration and how to optimize a bit the manual and automatic assembly inside SolidWorks. So I have a small diagram because I want to show a bit of interaction with Hydro. I already made the manifold, so today is not a session of designing manifold. It's basically a session with the purpose of understanding better how to set up manifold assembly constraints across components. So it's a small industrial block. I use it because there are several type of constraints of type of valves involved. As an example, I put linked to this port a fitting, tube fitting, Parker tube fitting. This valve, as you can see, has a Bosch Rexroth 3D model plus a bolt kit, and you will see how it is automatically assembled, but I'll explain how to create a bolt kit and how to link. This is just a cartridge valve. That's another cartridge valve. They have two differences because this one I use the type of cavity called sun cavity, although it's a Bosch Rexroth valve, but I use the concept of locating shoulder. Here we have a complex geometry, not complex in terms of how they are made in the block, but in terms of mating rules. It's a slip-in insert. Today I'll be showcasing slightly the latest version 985, which is not published yet, but we have an improvement on with the assembly rules for this type of component. So I take this opportunity to show it. We will have also a webinar related to the beta version next month. In this case, there is a slip-in insert and a cover. There are no bolts, so my exercise today will be building the bolt kit for this kind of cover. There is an orifice plug, and I'll explain a bit how the orifice constraints are set. So for those that already have Hydro, you are familiar with the export to MDTools. So if I do again MDTools, touch the envelope, and I can review the networks. Like I said, the block is already being designed, so I don't really need to do anything else. But as you can see, the CAD file is pushed out from the HydroCAD to the XML file, which will be used in MDTools. So that's my auto assembly circuit. So I go and start our exercise today. So I'll open my block. Let me switch to the design folder, and that's my auto assembly element. So in this case, the block, like I said, has already been designed, and I had already imported the schematic. As you can see on the left, all the items are already imported. You can see MDTools 985. It's not yet publicly available. It's just a beta, but it's okay for this for this purpose because I'll show you the new way of assembling sleeping valves. When you can always load XML file also on top of an already existing block. So I just load again my schematic. It's asking some, in this case, I have the same cavity split into 3 different folders, so I'll take the one that I know I have to use. And now that is done. So I want to play a bit with the automatic assembly, and then we go into details about how to set the constraints. So if I make a new assembly, and usually SolidWorks is asking you to place the block, and it will show you the list of open documents. If you don't want, you just click automatic assembly. MDTools will ask you to place the block. You can place the block from your folder, design folder. I want to take my solid part. And now MDTools will load the list of all the components. As you can see, it's loading the items like the proportional valve with the ball kit and like the sleeping insert and cover. All the plugs. The plugs are not visible in the diagram, but they are a part of every design. So almost all blocks except the very, very simple one, all the blocks have a construction plug. So by default, MDTools can assemble plugs, and they are set in the MDTools library. That's the relief valve. Those are again plugs. That's the check valve, again plugs. That's the fitting. And here we have the orifice plug. If we just click assemble, now MDTools will load, well, SolidWorks will load all the files and place all the components in the correct position. It's loading, and now we will see what happens. If you have any question, just feel free to post. I'll be able to read and answer on the fly. So as you can see, we have all the items assembled. Let me start from the fitting. So a fitting behaves like a plug or like a cartridge valve. So if you open this part, so this rule is valid for all users that want to assemble a cartridge style item. As you can see on the feature tree on the left, we have planes and axes. So basically, when we want a component to be instructed for assembly, we'll need to use the assembly constraint. As you can see, there are 3 items. That's the type of 3D model is a cartridge valve, and we have 4 other, but now we are focusing on cartridge valve. So we need to select a top face, a bottom face, and an axis. Although there could be different techniques to assemble the same item using SolidWorks mating, MDTools is structured in a way where you always need 3 items. It will not use all the 3. In particular, when there is only one item assembled to the cavity, it will use only the bottom face and the axis, but it's mandatory to select all the 3. So what you do is just you touch the top face, you touch the bottom face, and you touch the axis, and then you click set constraint. This command will show the green tick box, and basically you are instructing a 3D model to be assembled automatically by MDTools. So MDTools, if we go, let me not save, I don't need to save it. If we go to the mating, so if I go to the matings, and let me find the mating for the fitting, there it is. We have a coincident plane to plane. So this is a bottom face with the spot face of the cavity. And then we have a concentric, so the axis with the axis of the cavity. So for cartridge style assembly rules, this is what we need to follow. Bottom face, top face, axis. Similarly, if I open a plug, the plug, as you can see, has always the 2 planes, the top face, bottom face, and the axis. when I do training, I always get the question, why do I need a top face? You practically don't need in most of the cases, except on solenoid valves where you want to assemble a coil on top of it. But when you instruct a component for assembly, you always need to define also the top face. You cannot skip one of these. But the important information is that you need to do this once only for the 3D model, and then next time MDTools will always be able to assemble all these components automatically. In fact, as you have seen, all the plugs have been assembled automatically in the correct position. And it could take minutes, or if you have a very large block with hundreds of plugs, it can take hours to find out where to position the plugs and also the correct size. So in this case, it's very convenient to spend time in order to assemble, to define the assembly rules. If you want to specify, to link the 3D model with the correct plug cavity, you have to do it in the MDTools Library Manager. So let me open the MDTools Library Manager. When you are in the MDTools Library Manager, you go to the plugs. Well, before doing that, you will need to go in the options. Plug model is the path where you have all the 3D models. In my case now, my path is the 3D model SolidWorks. Since I'm using, and you are aware, if you already attended to some webinar, I use both Inventor and SolidWorks. I have different, yes, I use the same library with different plugs. So in this case, I'm using SolidWorks, and it is possible to link the plug. If you go to my BSP plugs, I can see that this plug is linked to the correct SolidWorks file. This plug is linked to the correct part. So you do the link between the position of the component in the center area. So I take 1x4 with 1x4 and click link. Of course, this component must have the assembly rules set in place, like I've explained a few minutes ago. Now let's focus on this cartridge valve. This valve, let me open the block. So this is the cavity, and as you can see, this cavity has a particular details called LS, so locating shoulder. This is not a sun cavity, but when you screw in this cavity, basically this valve will mate on this plane. So in this kind of situation, although the standard MDTools library does not define these cavities like this, I prefer really to use this behavior. So let me take the cavity DBD 10K, that's the cavity. So by using this checkbox, sun cavity, basically we are defining that this cavity behaves like a sun cavity, and we can define where the step for the locating shoulder is, which is item 3, step 3. And also it is possible to define a minimum locating shoulder. So usually this type of cavity is not synced up or down as a fixed position. So I put it 52 as the total depth. So it's 34 plus 18. There is no difference in the way MDTools takes the cavity information. It's different how you model the cavity here in the library. But basically, when you define a sun cavity with a particular locating shoulder, the bottom face has to be the locating face. So if I go back to my 3D model, open part, so this valve really has nothing on top. So there is no top face, but I had to select it in any case. So that's the bottom face. And the top face, I selected just a plain which is not needed in this case. So when I do the assembly, if we study the constraints, let me look for the DBDS. There it is. There is a plane-to-plane constraint inside the cavity. So it's taking the locating shoulder with the plane. And similar, there is a concentric axis. Now let's check at the stack elements. So in this case, I have a stack made of two elements. Basically, there is a valve and there are the ball kits. So as you can see, the ball kit has something strange here. I have made a ball kit with configuration. So it is possible, basically using SolidWorks features, to create different type of ball kit with the same assembly in order to be able to change the length of the bolt. Let me hide the body. So as you can see, if I take the ball kit here, I am able to change the depth just by selecting a different size. So basically, by doing this, I can link the ball kit directly in HydroCAD, depending on the type of footprint, and then in the assembly being able to change according to the maximum length I have for the bolts. So now I took a longer depth. Let's understand a bit how it works. So if I open it, well, that's just the part, but let me open the assembly. So as you can see here, we have the 6 bolts and we have configuration. So I can switch between configuration. If you're not familiar with configuration, I'll briefly show you and explain how to create them in SolidWorks so that you will be able to make them and do the same like I do. This is a particular footprint where we have 2 type of threads, M6 and M10. For all the other footprint, standard DO3, DO5, DO8, DO10, there is a standard thread. So this is the DO7. And normally I create a sketch, in this case, with the position, and then I mate the bolts with the sketch. But let's see how to make a bolt kit for the sleeping cover. So I go back to my block, and here let me show you again the block. So here we have the footprint, and I want to create the bolt kit for this this footprint. So we have M12, and the distance between the bolt I could see in the library manager as well, but it's 58 millimeter. So first I want to prepare the M12. I already have an M12 bolt, which is not yet has not yet configuration. So I'll show you how to turn a standard part into a configurable part. So let me go to the C working SolidWorks, accessories, bolts, and I take my M12 bolt. This is just something I have made on my own by using SolidWorks modeling. So I made a revolve cut, the drill, the head socket, and then the cosmetic thread. So now I wanted to make, as you can see, there are no configurations, so just a default one. I want to make a configuration. So I'll take just let me double click. I want to configure just the length. So when you double click on the sketch, you will see the dimension. You can right click on the sketch and use configure dimensions. This will open a table with all the configuration table. And of course, it is possible to add additional dimensions, but for this type of geometries, what I need is just the length. And so I can just, let me copy this name. I want a new configuration ISO 4672 M12 by 50, where the length is 50. And I want a ISO 4672 M12 by 60, and where the length is 60. And let me take also an ISO 4672 M12 by 70. You will be able later to add more. When you create configuration, make sure you type it below here a name for the table, for this table of configuration, so then it will be easier to modify it. So I will call it ISO 4672 M12 and click save. So then this table will be visible in the configuration table. Otherwise, it's a bit tricky. You will not be able to get back here. I can click apply and OK. Now, by doing that, I have the configuration. So I can switch between different lengths just quickly. And if I need additional configuration, I can open the table and just double click on the table and add a new one, ISO 4672 M12 by 80, and that's my 80. So by doing that, you are not forced to create all the different variation, but you can just quickly build what you need. In terms of bill of material, what is interesting is to be able to define part numbers as an example for every instance of this configuration. So with SolidWorks, what you will need to do is you can go to the properties of the file. I have created a configuration property called part number, which later I can add to my bill of material. So here I can say the part number is whatever you want. It is possible to create a new configuration properties, 80. Just type in like mole code. It's a text and you can type whatever you want. Of course, you will need to define the same attribute for all the items. So it's more convenient to first build one configuration, create a configuration property, and then you will see in all the other instance. Otherwise, you will not see, you will need to create for all the configurations, the custom property. Now that I have made my single bolt configurable, I want to make a bolt kit by using this. So I will make a new assembly. So this behavior is very different from what I have showcased in October using Inventor. There I was using iParts and iAssemblies. SolidWorks has really a different behavior. So usually I prefer to start with the sketch. So I put the sketch on the top face, and I'll make a rectangle, and I'll make the dimensions. It's 58 by 58. You are aware, if you are MDTools user, that MDTools is switching off automatic relation. So in this case, I will need to maybe mate. I take this dot with the origin and make it coincident. This one, it's just for construction. I don't need it for other purpose. For constructions. And this line will be vertical, and this line will be horizontal. For those that really use SolidWorks as a primary modeling item, you will struggle with this behavior of not having automatic relation. Remember, this is needed for MDTools behavior. So when MDTools is switched off, this is always switched off. I am referring to the sketch automatic relation, this one. If you want during modeling, if you don't need to design a block, you can turn it on. That's not a problem, but remember, this will cause issues if you are using MDTools, because We don't want automatic relation to happen when placing cavities. Otherwise, it's later impossible to edit. Now I put dots here. Since this is really a square, you could use the copy, but in case like of DO3, you don't really have a rectangular shape, so it's nice to learn how to place the component on a sketch. So now I have the sketch. I can position my component, my bolt. It's nice to take the origin with a dot and make them coincident. Yes, of course, the first item you place is fixed, so let me make it float. So it's driven now by the sketch geometry. And I can make a linear sketch driven. And the sketch is this one. And the item is this. And I'll make from component origin. So this is flexible. Basically, it's a copy driven by sketch. I can hide the sketch. That's no, sorry, not edit. I can hide it. Now, for assembly rules, well, this is a square, so really it's not important how I assemble, but let me go to the slip-in footprint. That's the BB08. When you set up assembly rules for footprint, make sure you select BH1 and BH2 as two axes. BH1, BH2. So basically here, let's say BH1 and BH2. So I go to MDTools tab, assembly constraint, valve pattern, top face. So nothing will be assembled on top of it, but take the top face. The bottom face is important, is the mating face. First axis and second axis. Set constraint. By doing that, MDTools is storing the constraint information in the assembly. So now we can save our assembly. We can call it NG25 bolt kit, but it's not yet a configurable assembly. So in order to make it configurable, what I want to do is just I want to configure the component. So for me, that's just the default configuration, which I can rename it as ISO 4672 M12 by 40. And I can make a new configuration, ISO 4672 M12 by 50, where I can select the by 50. And ISO 4672 M12 by 60, ISO 4672 M12 by 70, ISO 4672 M12 by 80, and here I can select the 70, the 80, and the 60. Again, remember, type in, so that's NG25 bolt kit, type a name and save the table, so later you will be able to edit, apply. Okay, we can test it. We go to the configuration tab and we can switch to different configurations. This is good. Now we can save it and we can test it, and later we can load it to Hydro library. Let us test it. We go back to the assembly. So let me open the cover, open. And let's check the top face here. So yes, the top face, as you can see, is the mating plane for the bolt, so it's correct. In the past, when I did older webinars years ago, I was really not keen on wasting time for the plane for the bolts. So frequently my 3D models, those I have, take the top face as the top face. In this case, if you want to assemble bolts, you need to take the top face as the bolt face. So this is correct. We can assemble it. We can do the assembly interface. So in the position NG25, I want to select the insert cover, and I want my bolt kit, NG25 bolt kit. Okay, update. And as you can see, the bolt kit are assembled properly. We can view them. So we have the plane coincident, we have axis 1 and axis 2, so the rotation is correct. We can also test if they can change. We can just go to the ISO M12, well, here in the bolt kit, and we can switch to the different one, 70, and confirm. Or again, touch and select a different combination. So as you can see, the configuration can have can control different geometries or just different information. So you can use configuration also when you have the same 3D model assigned to different model codes. So you can really create a variation of model codes, because eventually you can have a bill of material. In terms of bill of material, if we want to try a bill of material in SolidWorks, and I want to say only the parts, I can place my bill of material here. So now instead of putting in the block, I just put into the 3D model. If I insert a column, I will be able also to use my custom property. I should be able to find the part number. And there, as you can see, I can view the part number I have specified for all the bolts. M12, that's the M10. So I can read the custom part number that I have assigned to each configuration. So it is possible to control the bill of material, use the configuration as a unique single assembly entity, and later select which entity is represented in the bill of material. Now, if I wanted to automatically assemble this on the block, I'll need 2 steps. First, I need to load in the library manager. So HydroCAD has 2 pieces, HydroCAD and the library manager. In library manager, I can go to the CAD files and the load. Now I have a new bolt kit. It's in the accessory bolts. I have the NG25 bolt kit, and I want to categorize it. That's an accessory for me. Okay. Now this is in my library. So in HydroCAD, I will be able to take the cover and load together with the cover. I can load also the NG25 bolt kit. So now, as you can see, I have 2 items linked directly to the same component. It is possible to link an accessory tied to the 3D model so that MDTools will assemble automatically. As of now, in Hydro to MDTools, well, in MDTools, basically we don't support the assembly of the pilot valve on top because it has a different footprint. So if I go back to the assembly, we can see here that we have a footprint. As a rule for MDTools, the assembly is made one on top of the other if the footprint is the same. But here we have an NG25 and on top we have a DO3. So for now, MDTools is not able to handle. Hopefully we will be able to address it in the coming version of MDTools. Now let's test quickly this. So I can export again the MDTools, select. As you can see here, we will have also the ball kit export. Let me overwrite it. Let me load again on top of the block. And save my block. And now I go back to the assembly. Well, I can delete all. Let me get rid of all the components. Okay, and now let's try again the automatic assembly. Assemble. And here we have the 3 model with the bolt assembled properly. Now I want to explain how to instruct the assembly for the slip-in insert. Let me open. I have a insert which is not yet instructed. So it's my, well, that's an NG32. So let's test both. Let me open both files. So I want to instruct this to be assembled by MDTools. So this is just a cover. There is a pin here, which is describing the direction. So that's an NG32. BH1 is next to the pin and BH2 is opposite to the pin. So assembly constraint, it's a pattern. The top face. So here the 3D model already has the bolt, so I will make sure that I remove the bolts later. The top face is the plane for the bolt. The bottom face is the plane for the manifold. The first axis is next to the pin. And the second axis is opposite to the pin. Set constraint. Okay. And I can save it. Now this is ready to be assembled. Let me save into my content center so then it will be visible when assembling. So I go to C, working, 3D model SolidWorks, and Bosch Rexroth, LFA32, save. In the past, it was in order to assemble this kind of entities, we needed all the 2 axes, which was crazy. It was very complicated. Now it's much easier. Assembly constraint, we take the top face, bottom face, and axis, and set constraint. I found a bug on this version, so I need to flip the plane, but we'll make sure that in the release it will be fixed. So flip plane. So I just flipped the normal of the plane, and now I can save it in order to make it work, but in the release version, this will not be needed. Save as, and I'll save again into my working folder. Bosch Rexroth LC32. Now I can make a test block. Let me make a new part of a block made of 150 by 150 by 150. And I'll take my BC092A, item 2 on this face. I can save it as, let me save here as NG32, and I can test in the assembly. So I can place the block, assembly interface, select it, and I go to Bosch Rexroth, or I can search for LC32 A. Sorry, I also need the LFA32. I think it was LFA32D 7X, this one. So insert cover, and I don't have the bolt kit yet. Assemble. And as you can see, it's assembled, and inside we can see the insert, which is correctly mated. Last information for today's webinar is regarding the orifice plug. So if you have noticed in the automatic assembly, there was an orifice plug. It was in the diagram. Let me highlight it here. It's here, and this orifice had a 3D model. The location for this orifice is here. So if I go to the block, the orifice is below a plug, and if I add it, I can see the position. So from hydro schematic, basically the behavior is the following. Let me delete this orifice. So now the orifice is missing. You can double click, touch the plug where you want to place the orifice, and click OK. And now MDTools will create the profile, and we'll be able to connect it. I just use the stretch command here. Now the assembly rules for the orifice plug are very simple compared to the other one that we have seen. Let's see in action how they work. So I go back to the block. Well, since I recreated it, it asked me for update, but it's easier now to just do again the automatic assembly. I could just use the update. It will fix the constraint. But now let me show you the mating. So here, let me hide the plug. So we have the orifice below there. I did a configurable part like this. So I have the possibility to change the orifice size, which is good. So like I did for the bolts, in this case, instead of taking the length, I took the diameter for the orifice as a configurable dimension. Let me open this part so we understand the assembly rules for it. So the part is something like this. Well, I think there is also the cosmetic thread. Yes, it should be visible. Let me see if I just have to. Oh. Yes, okay. I don't see it. By the way, that's not a problem. I still have the configuration table. As you can see, it is later possible to add more. And if you just change the configuration, it will show you the different configuration with the different diameter. and that's it. In terms of assembly constraint, that is an orifice. So it's orifice plug. I never use orifice disk. It's basically same type of constraint, but for orifice plug, basically you'll need the bottom edge. So you can take the bottom edge and the bottom face. So these two constraints will provide the correct direction for the assembly, and that's it. Then you click set constraint and you are good. The expander plug is similar, bottom edge, bottom face. It's not different. In the past, MDTools had only these three. We later introduced the orifice, but since the expander is attached on top of the cavity while the orifice is below, we had to create a different type of constraints. But they behave the same. So if you want to automatically assemble expander plugs, you use the same technique: bottom edge and the plane. So physically, what happens in the assembly? Let me just see if I can. No. Let me make it remove the aspect. I want the transparency. If I take the orifice, there it is. Well, I want the constraints. I want there it is. So as you can see, we have it's basically adding two constraints between the bottom face and also the concentric. So it takes the edge as a concentric and the bottom face at the end of the thread in the model. Again, it may not be the most efficient way for assembling if you do manually, but this is done automatically by MDTools, so you should really not care because the position is correct and it's done automatically in the correct position. That's all the time we had today, so I don't see any question. I hope you enjoyed the webinar. So feel free to put comments or request clarification. I turn it over to Megan. Thank you again for attending.
All right. Well, thank you. That was very nice, Carlo. Doesn't look like anyone has any questions in the chat. If you haven't posted it, now would be a good time to do so. You can also email them to us at support@vestusa.com if you think of some questions later on. But that's all the time we have today to do the webinar, address any questions. If you do send us a question at support@vestusa.com, we will follow up within 24 hours. We would be grateful if you could complete a short survey at the conclusion of today's webinar. Tomorrow you will receive an email containing a link to view a replay of today's session. Feel free to share this link with your colleagues. A link to the view video segments from prior webinars will also be provided in the email. As you can see, we also have the webinar series posted on various social media channels. We invite you to follow these channels so that you can receive the latest updates on upcoming webinars as well as product releases. Our next webinar will take place in 2 weeks, where Carlo will demonstrate how to quickly build custom symbol libraries for enhanced productivity. Thank you again, Carlo, and thank you to everyone for attending today's session. Have a pleasant and safe day.